Okay, hypergeometric probability distribution. Hypergeometric probability distribution is a distribution with dependent trials whose outcomes are either success or failure. The random variable is the number of successes in a given number of trials. Probability in a hypergeometric distribution is the probability of X successful outcomes in R dependent trials such that A choose X times N minus A choose R minus X is divided by N choose R. Now, where A is the number of successful outcomes available in a population of size N. Now, the expectation for a hypergeometric distribution is the ratio of the expectation to the number of trials is proportional to the ratio of the number of available successes to the size of the population. So E at X over R is equal to A over N. And you can isolate for E at X to equal R times A over N. Now, so when you look at this and the explanations of this, you have to kind of understand what it's asking. With the expectation, you're looking at E at X over R. What that means is E at X over R is the expected value over a certain number R is equal to A, which is the probability of success, over the population N. So we're going to look at examples that involve this. Okay, example 1. On a team of 15 astronauts, 6 are women and 9 are men. If 4 astronauts are selected at random for a flight simulation, what is the probability that 2 men and 2 women are selected? Well, the probability of 2 men and 2 women means that we need to calculate what the success is. Well, we have a total of 15 astronauts altogether, and we need to choose 4. From that, on the top, we have 9 men, and we're choosing 2, times 6 women choosing 2. And when we do that, we calculate the decimal, and then we convert it to a percent. And that's when you round it to 4 decimal places. And that's it, folks. That's all it's asking. What is the probability that 2 men and 2 women are selected? Okay, moving on. Example 2. A bag contains 10 jelly beans. 4 are blue and 6 are green. 4 jelly beans are selected at random. Show that the probability distribution for the number of green jelly beans selected. Calculate the expectation and explain its meaning. So, we're going to do a probability distribution table. That is, we need to know how many green jelly beans there are. So that's our X. And then, so we're going to go up to how many jelly beans were selected. In our case, there was 4 jelly beans were selected. And we need to know the sum. Now, the probability of getting those jelly beans is again, okay, from the 10 jelly beans, which is 10 choose 4 on the bottom, we take 4 blue, we're choosing 4 blue, and 6 are the green, and we're choosing nothing because we want no greens whatsoever. Next, you take 4, choose 3, so 4 of the blue, we're choosing 3 blue, and 6 of the green, we're choosing 1. All over 10 choose 4. And again, 4 of from the 4 blue, 2 are chosen to be blue. From the 6 green, 2 are chosen to be green. Over a total of 10 choose 4. And again, we do for the next one, for the 3, it will be 4 choose 1 times 6 choose 3 over 10 choose 4. And the last one will be 4 choose 0 times 6 choose 4 over 10 choose 4. We calculate these values. The bottom number is going to be 210. In the numerator, we calculate the values. 1, and that has to have a total sum of 1, means that we've done this correctly. And x times p at x You multiply the x value times the p at x to get our some numbers that we're going to add together to give us our expected value. So you get these fractions, reduce them, and you get 2.4 when you add it all together. 504 over 210 is 2.4. So on average, 2.4 green jelly beans, there will be 2.4 green jelly beans in 4 selections. All right, moving on. Part B, you're asked to illustrate the distribution with a probability histogram. So again, along the x-axis, you're going to label it up to a value of, okay, so let's put this all together. So we're going to go all the way up to 90 over 210. So that's what I chose here, 9 over 21. And I went by fractions all the way down. You can do that as the answer. And so you have 0, 1, 2, 3, and 4. And if you'll notice that there are 2 values here that are hyper extended over everything else. So that's a hypergeometric distribution. Example number 3. 24 students have signed up to attend a workshop. 14 are female and 10 are male. 7 are randomly chosen to attend. What is the probability that at least 3 are male? So probability of 3 or more male. Well, we'll do the indirect method, folks, and it's 1 minus the probability of 2 male minus the probability of 1 male minus the probability of no males. How do we do that? Well, 1 minus the probability of getting a male, again, is going to be, from 24, we choose 7. Why 24? Because 14 plus 10, there are 24 students who signed up for the workshop. From there, 14 of the female, we want, remember we want 2 males and the rest female. So from the 14, we're going to have, from the 7, we're choosing 7. We have 14 females, and we're going to choose 5 females. And from the remaining males, which are 10 choose, what are we choosing? 2 males. Minus, on the bottom is 24, choose 7, because we want 7 from the 24 that's chosen. On the top, from the 14 females, we're going to choose 6 females, times 10 males, we're choosing only 1. Minus, again, on the bottom is 24, choose 7. On the top, we're looking at 14, choose 7, times 10, choose 0. Once we calculate all those values, we get a decimal, and we convert that decimal to a percent. Don't forget to round to the 4th decimal place. Next, Part B. What is the expected number of male and female students chosen? So the expected number is going to be RA over N. How do we calculate that value? Well, R is 7 that we've chosen from the population of 24, so that's where the N is. N is 24. We've chosen 7, and from that 7, we want how many males? Well, we have 10 males, so this is the expected value for males, which will equal 2.9167. So the expectation of males is the following, 2.9167. The expectation of females of 7 chosen is going to be 7 times how many females? There are 14 females all over 24, which will equal 4.0833. So you have a higher expectation on average, 4.0833 females will be chosen, and 2.9167 males will be chosen on average. Example number 4. During one summer, 500 foxes were caught and vaccinated against rabies. At that time, they were also tagged. 80 foxes were later caught to estimate the size of the fox population, and 34 of them have been tagged. Estimate the size of the population. To estimate the size of the population, we use the expected value. So expected value is RA over N. R is your, okay, so the expected value that we got was 54. Sorry, not 54, 34. Because 34 of the ones that we caught were tagged. Over, okay, now let's look over here. On this side, we have RA over N. R is how many were actually caught, that's 80, times 50, which is, 500, because there are 500 foxes that were caught, over N. Now, this may confuse a lot of you, and how did I get those values? So let's make it in a better form. Remember that there was another formula for this. E at x over r is equal to a over n. E to x over r equals a over n. What does that mean? Well, we had an expected value, expected outcome, which was 34, over the 80 that was originally caught. So 34 of the 80 had our expected value being tagged. Well, that equals how many were originally tagged? 500. But what we don't know is our n value. We do not know what the total population of the fox is, but we can gather it from the information that we have. 34 out of a sample of 80 was caught. 500 we know were tagged. So how many foxes do we have in this population? Well, folks, cross multiply and solve, and you have an n value of about 1,176 foxes in this population. Okay, folks, that's the end of the video. Have a numerical day.